In this video, let us see how to solve the simultaneous linear equation using direct method. Okay, so here again direct method we are having two methods called Gauss Elimination Method and Gauss Jordan Method. So as usual here let us consider the system of equation, that is here we have considered three equations with three unknowns. So for direct method we have to use a matrix method, right? So first we have to convert the system of equation into a matrix form. Matrix form means here we have to consider that is this system of equation is equivalent to the matrix form like this, that is matrix A into matrix B is equal to matrix A into matrix X is equal to matrix B. So what is matrix A? Matrix A is nothing but the matrix, the elements we are taking as the coefficient of the variable x, y, z, row wise, right? So from the first equation you take the coefficient of x, y, z and consider to be the first row of matrix A. Similarly from the second equation you take the coefficient, let it be the second row. Similarly the third row. Like this if you write this is the matrix A and x is nothing but the unknowns what we have to find out, that is here the unknown is x, y and z. Next is constant given in the right side, so that we have considered the matrix as B, that is B is equal to d1 d2 d3, right? So if you have the matrix A, X and B like this, then this system of equation can be written in the form Ax is equal to B. Okay, so from this we have to consider A and B and we have to form a matrix called as augmented matrix. The augmented matrix is denoted like this: matrix A and matrix B together should be represented splitted by a vertical line. So now this is to be considered as a single matrix and then we have to do the calculation using row operation. No column operation, only row operation we have to do. So using that row operation, if you calculate it, we can easily find out the value of x, y and z. Okay, so now let us move on to a problem. Let us consider the first problem. So we are going to solve the same problem using by Gauss elimination method as well as Gauss Jordan method. First let us see by using Gauss elimination method. First before that we have to write the augmented matrix A, B. Right, so how to write it? Already you know how to write A, B and X from the equation. So directly I am writing here A is nothing but we can take the coefficient of x, y, z. So first row will be 1, 2, 1, which are the coefficient of the variable x, y, z from the first equation. Second row you have to write it from the second equation. Third row you write it from the third equation. So like this you have to write this is matrix A. It should be separated by a line and then you have to write B. Matrix B is the right hand side constant value. So 3, 10 and 13. Now this is the augmented matrix. This matrix is called as augmented matrix. Now we have to use row operation. Row operation means actually for on what basis we have to use means we have to convert this matrix as an upper triangular matrix. Upper triangular matrix means what? We have to convert this value and this value as 0. Okay, that is the elements below the diagonal entries are 0 means it is called as upper triangular matrix. Now using row operation we have to convert these three elements as 0. So I will tell you how to do it. Okay, so now actually if you convert it into upper triangular matrix, that is called as Gauss elimination method. So now we are doing Gauss elimination method. Okay, so now what are the how to first step is initially at one step we can't able to convert all the three elements as 0. First step is we have to convert only these two elements as 0. Okay, so we have to convert only these two elements, that is we have to make this 2 and 3 as 0 making use of R1. Okay, after that only we have to make this minus 1 as 0 again. Okay, so first step we have to convert these two as 0 using R1. Okay, so now what is the formula for row operation? That is we have to change this 2 as 0, right? So that belong to second row, right? So we can mention it as R2. R2 is already we are having 2. 2 minus 2 will give you 0. So this R2 should be replaced by R2 minus 2R1. How we are writing this formula? R2 is nothing but the element 2 minus 2 will give you 0. So this that is we have to use only R1 to make this change. So that 2 here we want 2 means using R1 what we have to do, R1 already 1 is there. So directly multiply by 2. So that's the reason here we are multiplying by 2R1. Okay, so this is the reason like this we have to assign the formula or create the formula to make the value as 0. Similarly, how to convert this 3 as 0 using R1? So R3 should be R3 minus, that is 3 minus 3 we should have. So directly multiply 3R1. 3R1 is 3. So 3 minus 3 will become 0. So this is the formula for row operation to convert these two elements as 0. So while creating the formula like this, now we have to apply this formula for each element in that row. So if we are using R2, each element in R2 should be used by this formula. Okay, so similarly R3. So there will be change only in R2 and R3, not in R1. So we can in the next step we can write the first value as the same. There will be change only in the second and the third row. So now you calculate for this 2. So 2 minus 2 will give you 0. What about this element 3? 3 minus 2 into R1 is what? 2. Right? So what is the answer here? Actually, let me write it here itself. 3 minus 2 into 2. Similarly, for this element 3 minus 2 into R1. So here R1 is 1. So 2 into 1. Similarly here 10 minus 2 into R1 is 3. So like this we have to calculate. Do it for again R3, that is row 3. Again here this becomes 0. For this element it is minus 1. The formula here minus 3 R1. So minus 3 into R1 is what? R1 is 2 here. So we have to multiply by 2. Again here for the next element it is 2 here minus 3 into R1. So 3 into 1 here. Again here 13 minus 3 into this element R1 element is 3. So like this. If you simplify you will be getting the answer. Since we are using row operation we are getting an equivalent matrix. So we have to use the symbol equivalent symbol. And then here it is straight away directly equal to 1 2 1 3. First row there is no change. Second row 0 0. Here what? 3 minus 4 is 1. Minus 1. This is minus 7 1 minus 1 4 4. So this is the second step. Now for the third step we have to convert this as 0. So to convert this as 0 we have to use row 2. How here we are using row 1 to make the element in row 2 and row 3 0. Similarly here we have to use row 2. Okay, then only this value doesn't change. Already we have converted this as 0. No, if you go for again row 1, this first value will become non-zero. Then again we can't able to do anything. So we have to use only row 2 to convert this minus 7 as 0. So now what is the formula we have to write it for R3? So R3 is actually it is minus 7 using R1 I told you. R1 is minus 1. So minus 1 means with this which number if you multiply we can make it as 0. We have to subtract it and then we have to multiply by 7 or otherwise we can add it and multiply by minus 1. Both are same. Right? So this will give you what? Minus 7 plus 7 will give you 0. So this is actually we are taking the element from R3, this minus 7 and then minus 7 into R, this is what? R2. This is actually R2. So with this R2 we are multiplying by minus 7. So we can have the formula like this. So R3 minus 7 R2 will be the formula to convert this minus 7 as 0 in the next step. So likewise we have to identify the formula for row operation. So now considering this, now you have to convert it. So while doing like this, there won't be change in the first and second row. So write as it is. For third row already it is 0. If you use this also it will be 0 only. R3 0, R2 is also 0. So 0. Now for the second element, R3 is minus 7 into R2 is minus 1. Similarly for this element, minus 1 minus 7 into R2 is 1. Again for here 4 minus 7 into R2 is 4 again here. So like this you have to do the calculation. So this will give you 1 2 1 3 0 minus 1 1 0. This is minus, sorry, not minus, this is 0, no, this is what we have to make it as 0, and then this is minus 8, here 4, and then here 4 minus 28 is minus 24. So this is the matrix. Now if you notice this matrix, now this matrix A alone, if you look at this is an upper triangular matrix. So in this upper triangular matrix, after getting the upper triangular matrix, now we have to convert into system of equation again. So if you convert it to system of equation, again it becomes x plus 2y plus z equal to 3 minus y plus z equal to 4, and then minus 8z equal to minus 24. So from this z is equal to 3 will be getting. Now you mark it as equation 1 and equation 2. Now you put z value in equation 2. If you put, you'll be getting minus y plus 3 is equal to 4. From this what you will get? Y is equal to minus 1. Right? Actually minus 1 is equal to plus 1, or y is equal to minus 1. Now you put y and z in equation 1. Will be getting x. So x plus 2 into minus 1 plus z is 3 is equal to 3. So from this 3 cancel, minus 2. So x is equal to plus 2 is the answer. So now the solution for the given equation are x equal to 2, y equal to minus 1, z equal to 3. So likewise we can find out the solution using Gauss elimination method. The method how we are solving this from the equation is called as back substitution method, because we are going backward. That is, we are starting from z, using z we are finding second equation y variable, and then we are again using in the first equation. Okay, from third to second, second to first. So this methodology is called as back substitution method. So using back substitution method we have found out x, y and z value. Suppose in exam if you want to verify the answer is right or wrong, put these values in the given equation and you can check whether it satisfies or not. So for Gauss elimination method, you have to convert the matrix A into an upper triangular matrix using row operation. So this method is called as Gauss elimination method.